Good evening, class. This is the last section of Chapter 8. And at this point, you already know everything I have to tell you. In fact, this chapter is this section is just a sum-up section. It sums up everything we know. The first way it sums it up is this way in the picture. As you can see, it draws the shape. It says, all right, at the top we have the quadrilateral. And if I go down to the left, just like I drew in the diagram before, we have the parallelogram, rectangle, rhombus, and square. So we have that entire left side there. Another option for quadrilateral is the kite. And the last option is the trapezoid and the isosceles trapezoid. Another way that we might do this is by doing a Venn diagram, saying which parts overlap. So for instance, in this picture here, if I made the statement, a square is a parallelogram, you would say, yes, of course it is. It's inside the parallelogram bubble, and square is somewhere inside of it. Now, if I said a rectangle and rhombus, which, by the way, that is spelled wrong. It's not rhombi, it's rhombuses. All right, rectangles and rhombuses. If I said a statement, a rectangle is a rhombus, that would be wrong because I said a rectangle is a rhombus. Now, if I said a rectangle could be a rhombus, that severity level agrees. It could be, but it doesn't have to be. Okay. What if I said a trapezoid is a parallelogram? That would be a definite no, never. Okay, the bubbles don't even overlap a little bit. A kite is a parallelogram. No, never. Bubbles don't overlap. A square is a parallelogram. Yep, it's inside the bubble. Rectangle, parallelogram. Yep, in the bubble. A rhombus is a trapezoid. No, not even close to each other. All right, this is another way to kind of group them together. The last way is this big chart here. We've already done part of this. This middle part you should already have in your notes from section 4. This parallelogram, this right here, the rectangle, this rhombus right here, and this square was our left branch. Okay? We had the quadrilateral, but I didn't add the trapezoid or isosceles trapezoid or the kite to that flowchart. And I said the middle part would be the trapezoid and the right part would be the kite. At this point, I would fill in the rest. So, a trapezoid has exactly one pair of parallel sides. So in that middle of your trapezoid flowchart, you put exactly one pair of parallel sides. It's also true for isosceles trapezoid, only one pair of parallel sides, so two sides are parallel. But the legs, where's my mouse? There we go. The legs are also congruent. The common base angles, so those would be the base angle pairs, so like bottom left, bottom right, and upper right and upper left are all both common base angles, so they would be congruent. Now I didn't say this anywhere, but the uncommon base angles, so like this angle upper right, this angle bottom right, would be supplementary. And last but not least, the diagonals, if I drew them, would be congruent. The kite, there's 5 things that happen. However, I didn't call it 2 disjoint pairs of consecutive sides. I said 2 consecutive sides are congruent. Disjoint means here that they can't be overlapping. So I couldn't, in this case here, have segment ET be congruent to segment IT and segment IT be congruent to segment KI and say, hey, I have 2 pairs of consecutive sides being congruent. It has to be disjoint, which means no overlap. So the bottom 2 sides could be congruent to each other, and the top 2 sides could be congruent to each other, but the top sides and the bottom sides cannot be congruent. This definition of perpendicular, ignore. But the diagonals are perpendicular. Alright, the diagonals are perpendicular. And the diagonals bisect opposite angles. They do, but I did not talk about this, so you can ignore this one too. And there's one set of opposite angles being congruent. In this case, it would be angle E and angle I if I said the bottom 2 sides and the top 2 sides are congruent to each other. So, this one right here, diagonals bisect each other and definition perpendicular, ignore. But the diagonals are perpendicular and one set of opposite sides are congruent. This middle stuff you should already have in your notes in section 4. But here we go. This is the outline or the flow chart that is available to you. Alright, example 1. What types of quadrilaterals meet this condition? quadrilateral ABC has at least one pair of congruent opposite angles. Alright, so I only need one pair of congruent opposite angles. So if I go back to my flowchart here, one pair of congruent opposite angles. One set of opposite angles are congruent. Okay, kites. Done. Yes, kites are one of them. I look. Next one I look over. Both pairs of opposite angles are congruent. Opposite angles are congruent. Okay, it said at least one. So it could be both. So parallelogram also falls into it. But if parallelogram and kite, rhombus, rectangle, and square also fall into it because the parallelogram does. So all 5 of these would be the first answer I have to the first one here. Also, quadrilateral ABC has diagonals being congruent. So quadrilateral ABCD has those diagonals being congruent. So I'm looking for any quadrilateral that has diagonals being congruent. So I look, diagonals bisect, perpendicular, nope. Bisect, nope. Ooh, right here. Diagonals are congruent. So rectangles and consequently squares. Diagonals are congruent. Isosceles trapezoid. So I'd use these 3, isosceles trapezoid, rectangle, and square. So what types of quadrilaterals meet this condition? The second bullet down would be isosceles trapezoid, rectangles, and squares. And the last one, but not least, quadrilateral ABCD has diagonals intersecting at a right angle. Okay, so the diagonals are perpendicular is another way to say that. So I look, diagonals being perpendicular. Oh, kite satisfies it. Diagonals being perpendicular. Diagonals are perpendicular to bisectors. Okay, so diagonals are perpendicular. So rhombus, kite, and square. And that's it. So the last one here, rhombus, kite, and square. Basically, it's just an advanced matching game. You should have all these rules and all these things up in your head. And these 3 charts here are just a convenient way to apply them. Okay? Alright, the next example is, what is the name of quadrilateral ABCD? So I look at this. Well, I see diagonals bisecting each other in the first left one here. I also see over here that 2 pairs of consecutive sides are congruent and the diagonal is perpendicular. So if I think back over here, diagonals bisecting each other is enough to say it's a parallelogram. All those diagonals are congruent, which means the diagonals themselves are congruent. So the diagonals are congruent and it's a parallelogram. Diagonals being congruent to parallelogram. I'm thinking rectangle. Let's see. Parallelogram and diagonals being congruent. Rectangle. Yes. Even though it doesn't look like it. The left one here. Rectangle. The next one here. 2 pairs of adjacent or consecutive sides are congruent. 2 disjoint pairs of consecutive sides being congruent. Okay, I'm thinking kite. Diagonal is perpendicular. Diagonal is perpendicular. So the right shape here is a kite because 2 disjoint or 2 consecutive sides, 2 pairs of consecutive sides are congruent. Here, this is a rectangle because diagonals bisect each other and the diagonals are congruent. Alright, and the last one is enough information given in the diagram to show that quadrilateral ABCD is an isosceles trapezoid. Explain. I'm going to redraw this while you attempt it. So, the key thing I'm missing here is what x is. So let's find it real quick. All the angles of a quadrilateral add up to be 360. So let's just add them all together and see what I get. Alright, so x plus 180 plus 248 equals 360. Subtract 248 from both sides, I get x to be 112 degrees. So this is 112 degrees. So this angle and this angle is congruent. This angle and this angle is congruent. Now it looks very tempting to say isosceles trapezoid. But the question is this a trapezoid? It is. Because the consecutive interior angles of 2 lines, are supplementary. 112 plus 68 equals 180. However, If I would do the opposite, 112 plus 112, that does not equal 180. So I have only one set of parallel sides. And better yet, I have the base angles being congruent. This is a trapezoid because, it's an isosceles trapezoid because it has one set of parallel sides and base angles are congruent. That's pretty much it for this section. Is you're just trying to identify what shape it is, which ones satisfy it. You sometimes get more than one answer. For instance, maybe it's both a rhombus and a rectangle. It could be. Maybe it could be a parallelogram or a kite. Multiple shapes can satisfy these conditions I give you. You just have to match them up to the best of your ability. And you have to know the conditions to say, yes, this is a trapezoid. Yes, this is isosceles. Yes, this is a parallelogram. You're going to need to know all of it. Chapter 8, Section 6 is just basically saying, all right, you've already learned all this information. Just now decide which one to use and where. Try and pull it out and get it and use it. It's not just, all right, I've told you all these things and now test. It's, all right, I've told you all these things. Now let's try and put it all together and be able to pull it at random. Then let's get ready for that test. This is it for Chapter 8. For next time.